Measuring 35 meters long, 14 meters wide, and 11 meters tall, the Landkreuzer P.1000 Ratte was 1,000 metric tons of steel, designed to carry battleship guns across open terrain on caterpillar treads. Park a King Tiger next to it, the heaviest tank Germany actually mass-produced, 10.3 meters long and 3.09 meters tall, and the King Tiger looks like a retriever sitting beside a draft horse. Stand an average two-story house beside the Ratte, roughly 8 to 10 meters wide and 7 to 8 meters tall, and the house disappears. 3 of those houses laid end to end still wouldn't match the Ratte's. An engineer screwing around. Then someone showed Hitler. Edward Grote submitted the proposal that would become one of the most infamous pieces of paper in military engineering history. Grote was a director at Krupp, but he wasn't a tank designer. His background was submarines, pressure hulls, torpedo tubes, diesel propulsion systems built to push steel cylinders through salt water. He'd spent time in the Soviet Union contributing to the TG-1 tank program, but his core expertise remained naval. And when Grote sat down to design a land vehicle, he designed exactly what you'd expect from a man who thought in terms of displacement tonnage and watertight compartments. He bolted warship guns onto something shaped like a flattened hull and gave it treads. He'd already named it Landkreuzer, land cruiser. Then he added the designation that dripped with either dark humour or supreme confidence, and the historical record doesn't settle which. Ratte. Rat. His design originated from a 1941 Krupp strategic study examining Soviet heavy tanks, specifically the shock German forces experienced when they discovered their standard 37mm anti-tank rounds literally bounced off KV-1 and KV-2 armour during Operation Barbarossa. That study asked how Germany might respond to increasingly heavy enemy armour. Among the ideas it produced was Grote's contribution. If the enemy keeps building heavier tanks, build the heaviest possible thing and mount the biggest possible guns on it. The logic was internally consistent, the way a fever dream can be internally consistent while having no relationship to the waking world. Surviving design documents describe a primary armament of dual 28cm SKC/34 naval guns in a modified turret. The same turret fitted to the battleship Gneisenau, with the center gun removed to save roughly 50 tons of weight. These were weapons engineered to hurl 300-kilogram shells at enemy warships from 40 kilometers away. Now proposed for a vehicle that would share roads with horse-drawn supply wagons. Secondary armament included a 128mm gun, the same caliber that would later arm the Jagdtiger, and 8 20mm flak guns for anti-aircraft defense. Grote specified either MAN V12Z submarine diesel engines or Daimler-Benz marine diesels for propulsion. Power plants pulled straight from U-boat design manuals. Estimated top speed, 40 kilometers per hour. Crew requirement, 20 or more personnel. No European bridge could support a 1,000-ton load. No existing road surface could absorb that ground pressure without cratering. No fuel supply chain in Germany's rapidly tightening logistics network could keep this thing moving. None of those constraints stopped what happened next. Somehow, through channels the historical record hasn't fully clarified, Grote's proposal reached Adolf Hitler personally. Some accounts suggest the design was among those simply too ambitious for the standard approval process, bypassing normal evaluation entirely. Hitler saw it and responded with the specific enthusiasm he reserved for weapons of enormous scale. Enthusiasm that in the Nazi system carried the force of industrial mobilization. He approved the project. The Rat received a Führer order, meaning resources would flow regardless of whether those resources existed or could be spared from a war effort that was already consuming them faster than the economy could generate replacements. Albert Speer fought it. He had taken over as Minister of Armaments in February 1942 after Fritz Todt died in a plane crash, and by mid-1942 he was rapidly centralizing German war production, squeezing efficiency out of a system that had been shockingly disorganized. Speer reported directly to Hitler, and that proximity gave him both influence and a front-row seat to the Führer's decision-making process. He watched Hitler personally intervene in tank design, demanding heavier armor and bigger guns for the Tiger program, over the objections of generals who understood that a 57-ton heavy tank was already straining Germany's bridges, roads, and fuel supplies past their limits. He saw how a concept sketch could become a funded program overnight if it caught Hitler's attention. Grandiose projects devouring steel, engineering talent, and factory capacity that might otherwise have produced spare parts, ammunition, and fuel trucks. Speer understood the Rat as another instance of this cycle, a resource black hole dressed up as strategic innovation. He cancelled the project in early 1943. Not a single piece of steel was cut. No prototype, no chassis, no partial assembly. Just drawings, engineering hours, and bureaucratic oxygen consumed during the most critical months of the war. The Rat never left paper. But it got further than a joke should ever get. It got a Führer order, and allocated engineering bandwidth inside an armaments ministry that was simultaneously trying to keep ammunition flowing to Stalingrad. That approval chain, from submarine engineer to dictator's desk, reveals more about how Germany fought the war than the tank's specifications ever could. Hitler's fascination with superweapons functioned like an override, and the system delivered scale with increasing abandon as the war progressed, each proposal more extravagant than the last, each one justified by the failure of the previous generation of wonder weapons to deliver the promised victory. The Internet's preferred explanation for all of this is methamphetamine. Pervitin was distributed widely to Wehrmacht soldiers during the Blitzkrieg campaigns, and "they were on meth" has become the universal shorthand for every baffling German decision between 1939 and 1945. Good joke, earned its place. But it substitutes a punchline for an answer, and the actual mechanics were structural, not pharmaceutical. The Panzer VIII mouse proves those structural mechanics could produce physical objects, not just paperwork. Ferdinand Porsche, leveraging his personal relationship with Hitler to bypass conventional military channels, pushed through a super-heavy tank program that culminated in 2 complete prototypes. The Maus weighed 188 tons and was armed with a 128mm main gun and a coaxial 75mm secondary weapon. One prototype was tested at Kummersdorf Proving Ground. The testing revealed exactly what any sober engineer could have predicted. Top speed reached roughly 20 kilometers per hour on roads, a brisk walking pace. The vehicle weighed more than any bridge in the European theatre could support. Fuel consumption rates made the already voracious King Tiger look economical by comparison. Every ton of steel poured into those Maus prototypes was a ton that didn't become a Stug 3 or anti-aircraft shells for the defense of fuel plants that Allied bombers were methodically erasing from the map. Too heavy for any bridge, consuming fuel at rates that made the King Tiger look frugal, and yet 2 of them were physically assembled, driven, and tested. The Maus demolishes the assumption that the Rat was pure fantasy. If 188 tons could get funded, approved, and constructed in steel, then 1,000 tons occupied the same spectrum of escalation. Further along the curve, but recognizably part of the same trajectory. The tiger begat the king tiger. The king tiger begat the mouse. Had the timeline stretched, the mouse would have begotten the rat. So picture Edward Grote's position in June 1942. Submarine engineer, Krupp employee. Access to production charts and logistics reports that told the story plainly if you knew how to read them. The Eastern Front was grinding through men and machines at rates no industrial base could sustain indefinitely. Allied bombing was intensifying. Grote, at his desk in Essen, faced a choice with two very different timelines attached to it. Design something practical, something that gets manufactured fast, shipped to the front fast, and consumed by the Eastern Front's appetite for steel and flesh within weeks. Or design something so magnificently, so transcendently impossible, that it would take years to develop. Years during which the designer remains at his drafting table in Germany, rather than in a trench outside Stalingrad. The sabotage theory, and it must be labelled as theory, supported by circumstantial evidence rather than a signed confession, proposes that Grote and engineers like him were playing a fundamentally different game than their superiors understood. The rat, in this reading, was deliberate bureaucratic sabotage, a project engineered to absorb drafting hours, metallurgical studies, committee meetings, and ministerial attention, while producing nothing of military value. Engineers could see which way the war was going. Designing a 1,000-ton monster was a way to waste time and resources while staying off the front lines. Examine the design through that lens. Naval guns on a land vehicle, submarine engines in a tank chassis, a top speed claim of 40 kilometers per hour for something weighing 1,000 metric tons, a figure so optimistic it borders on satirical. Every major component Grote selected came from his own field of submarine and naval engineering, as if he'd taken a U-boat, flattened it, and welded on caterpillar tracks. An engineer told to design an impossible tank, one that needed to look impressive enough to earn Führer approval, but impractical enough to never reach production, would draw something very close to what Grote drew. Intent can't be proven from surviving documents. Grote left no memoir confessing to deliberate sabotage. But the structural incentives within the Nazi armaments bureaucracy were real, potent, and pushing every technically skilled man in the same direction. A Führer-approved project meant resources, staff, and, critically, desks that needed to be staffed, keeping the engineers attached to it away from the Eastern Front. By 1944, the alternatives for technically skilled men had grown stark. Luftwaffe ground crews and Kriegsmarine sailors from shore detachments were being pulled to crew armoured vehicles, because the training pipeline for armoured crewmen had essentially collapsed. An engineer attached to a prestigious weapons development program stayed at his desk, warm, fed, alive. Proposing something ambitious enough to catch Hitler's eye and impossible enough to never reach the prototype stage wasn't conspiracy. It was an emergent property of a system where survival and ambition pointed in the same direction, where the rational self-interest of intelligent men aligned perfectly with the irrational desires of the man at the top. Germany's fuel crisis was the soil in which all of this grew, and by 1944 that soil had turned toxic. The synthetic fuel plants that kept the entire war machine running were being destroyed faster than they could be repaired. The Leuna Works in Saxony-Anhalt, one of the largest synthetic fuel plants in Europe, absorbed 8,643 Allied bombs across 22 separate attacks, reducing its production by an estimated 90%. By January 1945, synthetic oil production across Western Germany and the Ruhr had nearly ceased entirely. The arithmetic was merciless. By late 1944, entire Panzer divisions sat paralyzed because there was simply no fuel to put in them. Finished tanks accumulated in factory yards without fuel to drive them to railheads. Panzer divisions at the front received brand new vehicles and lacked the diesel or gasoline to start their engines. An armoured force built for rapid manoeuvre was converting, week by week, into an expensive collection of stationary steel boxes. The rail network that connected factories to front lines was disintegrating simultaneously. Allied air attacks on rail marshalling yards were destroying finished vehicles in transit. Tanks that survived the factory floor sat exposed on flatbed rail cars, unable to maneuver or fight back, burning before they ever reached a unit that needed them. The production-to-delivery gap became an abyss. Getting a finished tank from a factory in Kassel to a fighting position in France or Poland required 3 separate logistical miracles: intact rail lines, available fuel at the destination, and a trained crew waiting to receive the vehicle. Those 3 requirements aligned less and less often as 1944 ground forward into 1945. The Battle of the Bulge made all of this visceral. Hitler's last offensive gamble in the Ardennes, launched in December 1944, required 5 million gallons of fuel to reach its objective at Antwerp. German forces started the operation with less than half that amount, gambling on capturing Allied fuel dumps along the advance route. The offensive stalled. Tanks, trucks and half-tracks sat immobile in the frozen Ardennes. Engines bone dry, halted 4 miles from a critical objective, stopped by empty fuel tanks rather than Allied firepower. The army that had blitzkrieged across France in 6 weeks couldn't drive 4 more miles because there was nothing left to burn. 2 observations were circulating that captured the contradiction perfectly. Those numbers look impressive until you trace what happened to the vehicles after they left the factory floor. Destroyed in transit by air attack on rail cars, arriving at depots without fuel, crewed by barely trained replacements scraped together from disbanded Luftwaffe units and retrained in weeks rather than the months proper armoured instruction required. A German general, staring at these numbers with the clarity that comes from desperation, literally requested they stop building tanks entirely and shift all production to artillery, weapons that required less fuel, fewer trained operators, and no complex logistical chain to deliver to the front. The war had moved past the tank as a decisive instrument, and some people inside the German military establishment recognized this with brutal honesty. Their recognition feeds directly back into the resource mathematics that made the Rat's logic perversely coherent, even as its engineering remained fantastical. 500 King Tigers required 2,500 crew members. 2,000 Stugs, producing roughly equivalent aggregate defensive firepower, required 1,500 additional crews, trained men who didn't exist in Germany's depleted manpower pool. A King Tiger burned fuel voraciously on an individual basis, roughly 2 gallons per mile, but you needed far fewer of them to cover the same frontage. When fuel is vanishing from every depot and trained crewmen can't be produced in sufficient numbers, concentrating both scarce resources into fewer, more powerful platforms has a grim mathematical coherence. If you can't fuel 10 small things, you may be able to fuel 2 big ones. That logic doesn't validate the Rat. The Rat was a catastrophically bad idea by any practical measure. But it was a bad idea that germinated in the same soil as a genuine and unsolvable problem. And understanding the problem is the difference between glib dismissal and actual historical insight. Now, the air vulnerability argument. 386 American aircraft found the battleship Yamato as she sailed on a one-way mission toward Okinawa. At 72,800 tons, Yamato was the most heavily armoured, most heavily armed warship ever constructed, bristling with dozens of anti-aircraft batteries manned by experienced gunners. 11 torpedoes struck the hull. Up to 15 bombs found their mark. Roughly 55 minutes elapsed between the first attack wave and the moment Yamato capsized and exploded, killing 3,055 of her crew. A 1,000-ton vehicle sitting on open ground at 11 meters tall, visible from miles in every direction, unable to maneuver beyond a crawl, would have lasted minutes against a flight of P-47 Thunderbolts carrying 500-pound bombs. Grote's design specified 8 20mm flak guns for defense, about as useful as throwing rocks at a thunderstorm. Against a squadron of ground attack aircraft, it was decoration bolted onto a target the size of an apartment building. But Allied air superiority was already killing the tanks Germany actually built. Allied fighter bombers strafed Panzer columns and hit rail yards where finished vehicles waited on flat cars. Strategic bombers cratered the synthetic fuel plants that would have powered whatever survived the journey to the front. Germany's armoured crisis ran deeper than any single vehicle design could address. A better tank, a cheaper tank, a bigger tank, a smaller tank. None of those answers mattered when fuel didn't exist, the rail network was shattered, and the sky belonged to the enemy. Other nations explored super-heavy armoured concepts. The Americans developed the T-28/T-95 super-heavy assault gun. The British built the TOG tanks, and the Soviets pushed their own designs heavier through the KV series and beyond. Thinking big wasn't uniquely German pathology, but the scale of German ambition, from prototypes that physically rolled under their own power at Kummersdorf to proposals carrying battleship armament, had no parallel anywhere else in the war. That scale was a product of 3 forces unique to the Nazi system converging simultaneously. A dictator whose enthusiasm could override every rational constraint. A bureaucracy where individual survival depended on feeding that enthusiasm. And a resource crisis so total that conventional solutions had already failed before the proposals reached anyone's desk. The Ratte was never built. Speer killed it in early 1943, and even without his intervention, Germany lacked the steel, the fuel, the transport capacity, and the industrial bandwidth to construct a 1,000-ton vehicle while simultaneously fighting a 2-front war, consuming resources faster than the economy could generate them. No quantity of Führer orders could change the thermodynamics of synthetic fuel production or conjure trained crews from a depleted population. What the Ratte represents matters more than what it was. A submarine engineer's sketch that briefly became national policy inside a system where fantasy and strategy had become indistinguishable. Every conventional path was blocked by late 1943. More small tanks couldn't be fueled. More crews couldn't be trained. Finished vehicles couldn't survive the journey from factory to front line. A general was asking them to stop building tanks altogether. In that environment, a submarine engineer's impossible design and a dictator's enthusiastic signature weren't aberrations from the system. They were the system functioning exactly as its incentive structure demanded, generating paper, consuming engineering hours, keeping skilled men at desks instead of in graves, and producing nothing that could alter what was already inevitable. The Ratte didn't fail because someone at Krupp was stupid or high. It failed because the entire apparatus that could entertain such a proposal was already dead, still twitching through the motions of weapons development while the fuel burned away and the bombs fell, and the calendar pages turned toward May 1945. The most unsettling thing about the 1,000-ton tank isn't that someone designed it. For a brief window, in a collapsing empire running on fumes and fantasy, it made as much sense as anything else Germany was doing. And that's not funny at all. Subscribe for more stories like this.